Welcome to Mastering the Supply Chain.
Exploring the fundamentals. Hi, in this video we are going to look into some of the topics related to the physical infrastructure as part of the building blocks of our operations and supply chain. Particularly, we will look into product and process characteristics, make-to-order versus make-to-stock, facilities and transportation. Let's start with product characteristics. First of all, the type of materials and product you deal with in your supply chain may put a limit on what you can and cannot do. For example, if I deal with inflammable material, I cannot store nor transport my product without specific safety measures. This is of course very different from dealing with fresh vegetables, which may require cooling, or packaged consumer goods, which may not require specific measures at all. A second very important dimension is what we call the value density of materials or products. The value density basically specifies how much money per cubic meter a material or product represents. You can imagine that a very expensive but very small item, such as mobile phones, will be dealt with differently from large but relatively cheap items, such as mass market furniture. Differences are, for example, with respect to transportation, storage, as well as the tied-up capital and inventories. In fact, to the value density as such, we should add another dimension, which is the so-called rotation, or the demand of a product, specifying how much quantity of it is sold or used. You can imagine that a very small and very expensive item would be of your specific interest due to its high value density. But if you hardly sell or use it, meaning that its rotation is very low, then of course its importance may still be relatively small compared to other items with a much higher rotation. After product characteristics are known, the process for sourcing, producing and distributing can be defined. Of course, it is not always strictly necessary that the entire product design has to be completely finished before the process design can start. If these phases can be overlapping, we typically speak of concurrent engineering, meaning that the product engineers and the process engineers work in parallel. Product design and process design are very closely related. This becomes particularly clear in case of changes to either one. Take the example of the pharma company that decided to change a medicine for children that was originally produced and sold as pills in so-called blisters, and which was changed to a product which was liquid, with a nice flavor and packaged as a toy. Whereas the attractiveness for both the child and the parent are clear, namely a nicer tasting medicine which in addition comes as something to play with, the operational consequences of this change were dramatic. Think of aspects like size, weight, type of material, and then think of the consequences for the existing pills and blister-based setup of sourcing, production, transportation and distribution. The next important topic with a large impact on operations and supply chain is the concept of make-to-order versus make-to-stock. Or, as some people prefer to say, the concepts of push and pull. For example, for a specific supply chain, one could choose the option of make-to-stock, which effectively means that the products are already prepared, produced and transported to the area close to the market, waiting for the customer to appear and buy. The product is pushed to the market, but it remains uncertain if it will be sold until a customer actually really appears. On the other extreme, one could choose for make-to-order, effectively doing nothing in terms of producing and transporting until a customer places a specific order, which is then the trigger for all activities to start. In this case, it is the customer who pulls the product towards them as soon as they need it. Other options of push and pull exist, such as assemble to order or even engineer to order. As a reflection, you can think about which you think are the pros and cons of a more push-oriented approach in comparison to a more pull-oriented approach. Important to keep in mind is that the activities on the push sides are based on forecasting and can be focused more on efficiency, whereas the activities on the pull side are based on existing customer orders and can be focused more on speed and flexibility. A slightly more tangible topic then, facilities and transportation, also important parts of the physical infrastructure. Here a reflection rather than an explanation. Think of which types of facilities and which types of transportation we can distinguish, and which decisions we will have to be made about them. As a consequence, what can you see as the implications of those decisions for cost, speed and flexibility? Finally, a few words related to capacity and particularly scalability, upward as well as downward. If demand is not stable but variable, or if demand is growing or sometimes falling, then a certain degree of scalability comes in very handy. But this scalability comes with a number of questions to be answered. For example, do we increase capacity before an increase of demand materializes, or do we prefer to wait until it is there? Can we increase gradually, or can we only do it in big steps? This then leads to the reflections you can do after this video. In terms of scalability, which ways do you see for gradual increase or decrease of capacity? Which ways do you see for big step increase or decrease of capacity? And which ways do you see for flexibilization of capacity in order to be able to easily scale capacity up and down? And to complete this video, one more series of reflections you can do after watching. These ones about uncertainty of supply. What could be the internal or external reasons for uncertainty in supply? What can be done to mitigate the risks associated to the uncertainty in supply? And how could supplier collaboration help in order to reduce uncertainty and improve performance?